Hello, my name is Sri. I spoke to you all yesterday, and the feedback I got as part of the meeting was that we were not able to cover the topics as expected. So, what I will do now is I'll record quickly a video for you. Let me just turn on Do Not Disturb. I'll record quickly a video for you so that I can fulfill my promise of covering idea to prod with GitLab. All right, let's get started. Let me share my screen. Hope you can share my screen now. I'll go back to my slides. The topic is going to be broadly about DevSecOps with GitLab. What can we do um, to improve our processes so that we don't have silos anymore, but our organization works as a single team? That's basically the goal. As you probably know, GitLab is a complete DevOps platform. While many of our users use it as SEM or pipelines only, it is possible to actually do much more with GitLab. All right. So this is a typical scenario we see with many of our customers where they have a lot of tools in place. And while these individual tools are great by themselves, the integration points often get messy and need a lot of maintenance. So GitLab tries to solve that problem by having a single application for the entire stage. So right from planning and management to the actual development processes to the release cycles, and of course, once it's been released, to monitor and defend your application. So this is what we call the complete idea to production journey. And we'll get into specifics. The specifics are that we're going to look at specific roles: planners, developers, security, and operations, and see what we can do. This is a McKinsey report that I got hold of recently. It's actually quite recent. It's from May 2020, and it talks about how organizations can fulfill the promise of DevSecOps. And I was surprised by how neatly it ties into the GitLab philosophy of how you do things the GitLab way. So there's a link right there. You can visit it and read the report. I think it's freely available. And quickly going to highlight a few points from that paper which apply to us. So firstly, adopting DevSecOps, you want to make sure that your teams aren't silos, but they're actually teams. So cross-functional teams. Your planners, your creators, your developers, your designers, your ops teams, your infra teams, your security teams. All of them should act like one team, which take a feature from idea to production. So that's the key. You want to have, as the second point, consumable developer-owned operations, which means that ops teams create pipelines and jobs that are reusable. So if I, as a developer, want to get started, I already have an operation team member who has created for me the pipeline that I want. So I can just pull in that pipeline, or I can just pull in that particular job. I can configure it the way I want, and I can get started as quickly as possible. Point number 3, automated pipelines with built-in security. So this is where we want to make sure that security is never an afterthought. It's not develop something for months and months and just before the release do your security at that stage. No. Do the security as early as possible. In fact, we'll see how we can do security in the best way possible by following the proper Git and the GitLab flow. Then you want to make sure product architecture is secure by design. This is not something an external tool can give you, but it's something that you should be mindful when you create the architecture patterns for your applications. And what you want to make sure is that culture should be such that everybody wants to take responsibility of everything. So it's no longer the silos culture where, hey, it's not my job. My job as a programmer was to write code. Now security guy has to fix it. No. It's like everybody owns every part of the process. Common pitfalls that some organizations face: focusing on tooling alone. Tooling alone is not going to do it for you. Tooling will make it simpler, but you want to make sure that everybody as an organization, everybody wants to play a larger role. Pitfall number 2, failing to secure leadership buy-in. So something can be a good idea for a small team, but to have an organization-wide impact, you want to make sure you want to get to the very top and make sure that the organization's direction is set right from there. Another common problem we see is that organizations only do things right in greenfield projects and not across the entire IT landscape. So I think it's fair to say that about 95% of your projects will not be greenfield projects. There will be legacy projects that you want to maintain over time. So you want to do things right for those projects as well. Pitfall number 4, taking too long to deliver value. Well, if you want to make a transformation and the transformation takes 7 years, it's not really transformation. It's more like a slow motion transformation. And then by the time the transformation happens, you don't even know what you've achieved. So we don't want to do that. We want to do specific small things, time box, to deliver value as quickly as possible. All right, I'll just move on now. So this is the general adoption scenario. It's not really important for this. I'm going to bounce off. Let's talk about portfolio and project planning. So this is, if you remember this slide up here, these are my 4 roles: planners, developers, security, operations. We're going to start with the first role for the planners. So you want to plan either short-term or long-term, but I will build up the story and go from there. So let's say we want to start from the very beginning. The smallest unit of actually planning is an issue. So you describe what needs to be done in the issue. You can see an example over here where the issue has a title. It's got some tasks, and it's got some information on the right. It's got people it has been assigned to. It's got some kind of time tracking, milestones, labels, and the likes, right? So just keep that in mind. One thing I would like to highlight is that the issue is also the place where you refine it. So you have discussions with subject matter experts or with developers or the Scrum Masters, and you make sure that the issue goes through this churn where the issue gets refined and it's ready to be acted upon. So this can happen through discussions, either offline or on the issue itself. You can discuss offline, but make sure you capture the result of the discussion in the issue so that it serves as your single source of truth. Another thing you want to see is that issues can be assigned to people. So I know my specific people who will work on it. And then once it has been assigned to people, you probably want to do some sort of estimation. So estimation is done by a weight of an issue. So weight can correspond to story points. So you want to make sure that big issues have heavy weights and small issues are lightweight. And of course, you have milestones and due dates to track those kind of things as well. Okay, but you'll never have just one issue, you'll have many issues. And the most basic way of seeing many issues is through a list. So here's a list of issues, pretty straightforward. You can see that I have, I don't know, maybe 10 issues listed out here. And there are some little colorful things, which are basically labels. So I can assign labels to my issues, which let me organize things properly. Once you see a list and you see many lists, over time it gets boring. So I want to not just see lists, but I want to see lists in some other context. Enter storyboards. Storyboards, again, built right into GitLab, and it gives you functionality that's quite similar to Trello. So you can use this for a lot of reasons. But basically what it is a column-based layout where every issue listed in a column has certain criteria, which is why it gets listed. So in this case, you can see simple example based on status, that is open, UX, planning, front end, etc. Those are the criteria of the issue listed. And quite possibly there's going to be a workflow where you grab an issue from here, move it to in progress, or move it to close based on how and when people act on things. Jump right ahead. Here's an example of an issue board. It's actually my issue board. You can see right here, Shree's board, and this is all the work I'm doing. Apparently, I'm not doing any work. I've got my to-do and doing boards empty, but I've got a lot of tickets in my open and closed sections, and you can see I've blacked out specific areas which mention customer names. So hopefully those are grayed out. Moving on, release and workflow boards. So a very common use case for boards is to track releases. So you want to go through all the phases of a release, for example, development, testing, production, and ready. And then as you cycle through this, you move your tickets from A to B. So that's a very common use case. Another common use case is a topic board, where you have a long-term epic which will take several months. In this case, this is from the GitLab project itself. The topic is database sharding, and database sharding, you have to do a lot of work for achieving that, right? Because we're gitlab.com, we've got hundreds and thousands of users on the platform every day. If you mess with the database, you have to be very careful. So you do it in many different issues across many different releases. Here you're seeing the work is being done. There's a lot of work that needs to be done. And some work was done in the 12.10 release. Some work was done in 13 release and 13.1 release. So you have all of that information as well. That brings us to epics. So now we're talking long-term planning, and you want to not capture specific issues for specific tasks, but you want to capture direction for your organization, what you want to do. So one thing I'll highlight quickly is that your organization can be nested. So you have a top level organization, and within that organization, you have many departments, and these departments have got many different teams in them, and those teams are working on many different projects. So you have like a hierarchical layout, and you would want to capture the epics at the right level. So if the CEO has got a goal for the entire year, he's going to capture that at the top level. But then if you are a department lead and you want to make sure that all your teams follow a certain direction, you capture the epic at that level. If you're a product team and you have, let's say, a web-based product, but also mobile apps for iOS and Android, and let's say that at the product level, you have decided that your buttons should be not green, but they should be blue. But you have to implement this across the web platform, the iOS platform, and the Android platform. You have to do it at different levels. So that kind of work can be captured by epic relationships. So epic at the top level will capture the global direction. And then for your specific group, for your specific project, you can create sub epics and related issues so that the epic gets broken down into specific things that specific groups have to work upon. Milestones is another feature, straightforward actually. You want to have time-boxed planning. So if you say that I have a sprint, or let's say I have a release, you want to create a specific start date and an end date for that. And then within that milestone, you want to assign a lot of work. So this is an example of what we do at GitLab itself. We have releases for milestones. The next milestone is 13.1, which is going to be released on the 22nd of June. So about 7 or 6 days for that. You can see right now it says it's 39% complete. 39% might be a bit dated because the screenshot is from last week. But yeah, so we use it for tracking. Now you take milestones, you take your epics, you take start dates and end dates, and then you can visualize that for your entire organization. You can visualize what work needs to be done and when it will start, when it will end. So this will give you a beautiful roadmap where you have issues and sub-issues and epics and sub-epics laid out over time based on your milestone dates. This is a very useful feature, especially for large teams which have to manage and plan a lot of things. Again, I've briefly walked through the basics, but now I'm going to get my hands on with some demos. Before I do that, I must also mention that we have first-class Jira integration, really solid Jira integration, which means that if you use Jira and you want to stay with using Jira, you don't want to migrate everything to GitLab, which is quite understandable, then you can achieve that as well with minimal pain. Let me go to my demo project now. I'll create a subgroup for this demo. Let's say demo BICS. Today is 20/06/16. Just create a group for this demo and increase my font size, of course. Let me start off by creating a new project. And let's say I want to create from template Ruby on Rails use template ROR hello BICS. Right, this is going to be a project. I'm going to create it. You will see a few things happening now. I'm going to start creating a project, which means there's a project and a Git repository. For this Git repository, what I have done is I've included a very basic Hello World project, which is Ruby on Rails. I'm going to enable Auto DevOps as well. Let me do that. I'll explain Auto DevOps a little later. Let me just quickly enable it and get going. Let me just select a deployment strategy and move on. Okay, good. So now let's do the basics. Let's go to the plan. I'll go to issues. I'll go to boards. Let me create a basic board. So I've got open, to do, doing, and closed. All right, looks straightforward. Let me collapse this and get more space. Screen. Okay, I want to say hello BICS. I want to say hello BICS. That's my issue. Let me go right here. I'm doing it. So let me get into the issue right away. All right, so let me jump to the slide and explain a concept now. Now we're working as a developer, right? The product owner has created the issue for me. It's there. Now Shri, the programmer, has to work on it. So basics of what we will do, we will work a bit with Git. So as you know, GitLab is based on Git. So you get all the benefits of Git. You get decentralized version control, cheap branching, conflict resolution, and high performance. That's what you get with Git. What you also get is the GitLab flow, which is basically a standardized way of working, wherein my master branch is my stable production ready branch. And whenever I want to do some work on this branch, I have to branch off into a feature branch, do my work there. I do the work in the separate branch so that I don't break master. So master has to be production ready. So I work in a feature branch, and in that branch, I push my changes. Once I push my changes, some automated tests will run, scans will run, and then those scans have to pass, and my organization's human approval process has to follow. And once all of that is done, I can merge it back into master. So we're going to see that right now in the application. So let me start off. I'll create MR. There you go. Looks straightforward. I'll open the web IDE quickly, and I'll change this application. Let me go right here, app. Can I go into welcome? And it says you're on Rails. Now I will say, hello, BICS. Sorry for going off topic yesterday. So let me copy this entire text. This is my one change. You know what we do as a good programmer? You have code and you have tests against the code. So let me go look at the test. I see the test out here. Let's see if I can find its system. Is it in system? No. Is it in controllers? Yes, welcome. There you go. Controllers, welcome. It's expecting you're on Rails. No. You should now expect this. That's my change. Pretty simple. Let's review it. I've got a change in the text in the text of the test, and I've got the change in the text of the main application as well. Commit. Okay, great. A few things are going to happen now. I've got, let's say I've got buttons on the right. You can see the pipelines. You can see the live preview, and I'll show you the terminal as well, right? So we have a few things right here, but let's start with the pipeline. So it started executing a pipeline for me. And you can see that I'm getting all these jobs for a perfect pipeline, stages and jobs. Why and where is this happening from? So if you remember in the beginning of the demo, I enabled Auto DevOps. So what is Auto DevOps? It's pretty simple concept. It's like we give you a default pipeline to begin with. Now you can use the default that GitLab gives you, or you can create, for my organization, I can create a customized default. So you can have one default pipeline for the entire organization, or you can have specific default pipelines for specific groups. So you can create these defaults. Once you have the defaults, of course, the pipeline can be used by any team that wants to quickly get started. So you saw that I wanted to quickly get started. I did not write a single line of pipeline code. I just have a perfect pipeline available with me. While the pipeline runs, let me just walk through my slides to just cover the concepts again. So we saw that I created an MR from the issue. So in this particular example, I had one issue and one MR, but that's not always the case. I can have a really large MR that fixes multiple issues, or the other way around. I can have many issues that are fixed by one MR. So you can have like a many to many relationship between them. We also will do a few things in the MR itself. We're going to look at that the merge request is actually the heart of a developer's workflow. So from here, you can see the code changes. So let me just show you that. Let me go to merge requests, and let me go to this merge request. So if I'm a developer and I'm working on a feature and you are my colleague, you're interested in what I'm doing, you can go to the commits tab. Okay, Shri has pushed some code. Let's go to the changes tab and see what those are. So you can quickly scan what's going on. The next thing you can do is a code review. So you can say, hey, this is not right. Let's talk about it. So you can say, let's talk about it. And you can start the review process. Now, your organization can have its own rules, as in how many people must approve, what should be the review process, those kind of things. In this case, let's assume that I am reviewing my own code and I think I like it. So I'll finish the review, submit the review, right? So in this example, very simple, but you can have a complex review process where multiple stakeholders have to review code. Then builds and tests. So this is where my pipelines come in. You can see that I go to the pipelines tab and I see the status of the jobs. So the jobs are pretty straightforward, right? You have a lot of jobs out here. And you can see that the build and tests are executing, and it's going to execute a lot of other jobs. So I have a quick overview of what's going on. Security scans, this is my point now. So a lot of these jobs listed out here are actually scanning the code for security changes, right? So if I make a change that impacts the security of my application, I will get notified right here in the merge request itself. Now, this is a large topic and I can talk for a long time about this, but let me just say as follows. We have support for a lot of programming languages, about basically all of them, the major ones. And we pick the best of breed open source tools to run all the scans. In this case, let's have a look. We're looking at Breckman, which is amazing for Ruby. We're looking at ESLint for the JavaScript part of things. We're running retire.js for the dependency scanning. So we're scanning if your dependencies are out of date or not as well. We have SAST for secrets, which checks the code for things like passwords or API keys. You want to make sure those are not introduced. We have Node.js scans. In this case, Gymnasium, which is again dependency scanning. We have code quality scans coming from code climate, and we have like so much here. So I can we can talk about license scanning. For example, your organization might have a policy in which certain licenses are allowed, some others are not allowed. That gets scanned right away. And of course, the container scanning, which is like dependency scanning, but you scan the container image versions to make sure that the image versions are as secure as they should be. Most importantly, if I can take you back over here, if I can take you back to a slide, maybe here. So most importantly, you must remember that these scans are happening in the feature branch, which means my master is remaining untouched. It's stable. And all these scans will execute on the feature branch, and only when all the security standards have been met can I merge it back. So this security first or shift left workflow is a key part of working. Let's have a look at security scans, then a review and deploy process. I'm going to walk you through that as well, waiting for the job to fulfill. We're going to look at the review process and the approval process. I can talk a bit about approvals now, because approval workflows are a big topic in a lot of organizations, right? So you can have approval rules where certain people, let's say important senior people belonging to certain groups, let's say a senior front-ender or senior back-enders, senior QA, they must approve a merge request for it to be merged back. You can have a rule like that. Or you can say that I'm going to use the code owners functionality, in which I describe who owns what part of code, and based on the code owners, the approval processes will be such that the owners will have to approve a change. That's another option. There are various, like you can keep things as simple or as complex as you like. A fundamental question that I get is, okay, these pipelines, can you tell me more about the pipelines? So what is a pipeline? As you see over here, a pipeline is nothing but a bunch of jobs that were triggered automatically when I pushed some code. What are the triggers of a pipeline? So let's talk about when do pipelines get executed? When certain actions take place, when certain events take place. In this case, the event was a push to the repo. So if you create a branch on a repo and push it, or if you create a tag on a repo and push it, or just have a change and you push that change, or things like merges and rebases and the likes. So whenever you make change on the repo, the pipelines gets triggered automatically. Sometimes my pipeline can get triggered based on the result of another pipeline. So you can have multi-project pipelines as well. And of course, you can trigger them programmatically through an API, or from the GUI, you can trigger a pipeline by just following a form and pressing a button. That's that. I don't want to get into too much details about pipelines right now. Just quickly going to cover some aspect. There's a GitLab instance. There are some GitLab runners. The runners are responsible for running the pipeline. They can run your pipelines on a host of different platforms. Most common are either Kubernetes or virtual machines, or actually Docker itself. gonna jump right in. Okay, I don't want to get into this right now, but just for your information, GitLab pipelines are written in code. So the pipeline lives in the repository, and we use YAML as a language for writing the pipelines. They have stages. So stages are basically sequential execution, whereas the jobs can belong to these stages. For example, in this case, in the prep stage, there are 2 jobs, and these 2 jobs that belong to the same stage will execute in parallel. Yeah. So these jobs execute at once, while after all these jobs execute, you move on to the next job out there. That's that. Actually, here's an example. You're seeing that in the test stage, I've got 2 jobs running at the same time. Actually, all of these ran together and they passed. These 2 are still running, and we're waiting. We're waiting for these 2 jobs to fully pass until you move on to the next stage. Jump right in. There are some complex exceptions. In some cases, you can make sure that certain jobs execute based on the dependencies that they have. So you can create all kinds of rules for that. Again, it's a detail that I can share. For larger projects, for monolith projects, it's common to have parent-child pipelines, or as I like to call them, nested pipelines. Again, it's a detail, but it's possible if your code base is huge and you have a lot of different pipelines happening and you want to make sense around them, this is an option. Security and compliance is usually a pretty big topic. So I would like to talk about that as well in a few minutes. Let's see if I have the time for that. So with GitLab, we make 4 bold claims around this. We say that 1, we're going to destroy silos between your developers and your security teams. 2, we say that developer workflows will never compromise security. 3, we say that we give you built-in tools and we integrate with your external tools as well. And 4, we give you like an organization-wide single source of truth of what's going on. So let me quickly walk you through this. When I say the first claim, destroy silos between developers and security. Here's the problem. The problem is that developers have their own tools, security engineers have their own tools, and these tools are wonderful. They're great tools. You know, they need to exist, but every tool has its own dashboard. Every tool has its own reporting style. And when I want to identify the root cause for a particular issue, I have to jump through many different tools. And many times I have to authenticate myself in many different tools. It's just a very inefficient way of working. So what do we offer? We offer a single application, which means my security officer and my developer is in the same application. And there is seamless navigation from the reporting of the issue back to the root cause and further what next steps you have to take. So here's an example. This is an example of a security dashboard. You're seeing that I'm seeing a bunch of issues out here, 3 of them critical, 2 of them high. Let me say I select an issue. If I select an issue, I get some details, right? I see which project it belongs to, which report it came out of, what is the CVA, and things like that. Most importantly, I see a link which takes me to the file and the line. So I click on the link, it takes me to that specific file, and that highlights that specific line where the issue exists. In this case, the issue is that the secret access key is written in plain text inside the code. This is a big no-no, right? You don't want to do this. And I scroll to the top of this file. I see that this change was made by Marcel 1 week ago. And I see, okay, this is what he was trying to do, and he made this change. But what's next? I can contact Marcel, or I look at the code owner's information. I know exactly the people who are responsible for this. So some of them may have even approved this. So my next remediation step would be to identify these people and speak to them and ask them what's going on. So I, as a security officer, was able to track what went wrong in the dashboard down to the specifics, exact file, exact line of code. From there, I was able to go to the person responsible for authoring that and his team members who were responsible for fixing it or who are responsible for the code in the first place. So I have all that information really quickly in single application. Makes my life really simple, right? But things get even better. We say that developer workflows never compromise security. And this is a replay on what I actually mentioned earlier. We have 3 rules. We want to scan early, scan often. We want to provide instant feedback, and we want to protect branches and that are always deployment ready. So you can see the GitLab flow. Here's a different version of the same thing. I have a master branch, but when I have to work on a feature, I branch away. which means my master remains untouched. I work on a feature branch, I do my changes, my pipelines execute. Part of my pipelines are also all these security scans, and I get feedback from the security scans right in my MR. So here's an example. Here's an MR, and you can see out here, security scanning found so many issues. I go into that, I see the details of my issue right here. Now me, the author of the change, sees this, but you who are going to review my change, you also have this information. So you will not approve my changes unless all these issues are fixed. And there can be some cases where you either, it's a false positive, let me close this please. Either it's a false positive, wherein the issue is not really an issue. So you can just, you can say, I'm not going to work on it. Or you can say that, this is an issue, but we have to introduce it and we can create a subsequent issue to fix it later. So that is an option as well. But most likely, and let's say 95% of the time, we want to fix the issue right then and there so that we don't introduce it into the master branch. Again, sometimes issues are simple to remediate. For example, let's say I'm using a library, in this case, SAML2JS 1.14.2, and that has got an issue. But SAML.js just released a patch, so they've got 1.14.3, and it's easy to apply. Now, do you really want me to go back to my code, fix it in the code, and push another change, and then resolve the merge conflict and so on? No. You want to automate this process as much as possible. Press the button. Auto remediation of issues that are commonly fixable. So what did we just see? We saw that the master is always stable and prod ready. If an issue gets introduced, we scan early, we scan often. We show it right then and there to the author and to the reviewers. We make sure that you cannot merge it back. So we preserve the sanctity of the master branch, right? And master gets only changed when pipeline scans are successful and multiple humans approve the change. Again, make the security team a stakeholder. Let it not be just the devs, testers, and QAs and likes. Make the security team a stakeholder. Make the security approval group necessary for approving merge requests. Why not? Built-in tools, again, I showed you quite a few of these tools out here. You can see a lot of these, and there is a lot of documentation where we share which exact tool is used. One thing you just saw is that my review application was successful. That's an interesting feature. So let me show you what that does quickly. Let's see. If I go to my merge request right here, and let me go right here, and I say, and now I'm playing the role of the product owner again. I wanted this change, and some developer worked on this change for me. I want to review it. The review app button is available in the MR itself. So if I can share with you, where is it gone? If I can share with you this cycle. So now we're at the step 5 of the review cycle. We've done code changes, we've done code reviews, we've done built-in tests, security scans. Now we're at step 5, review deploy. Let's check out the review application. So what this does is it automatically, GitLab automatically creates an review environment for this specific branch. And let me just accept the SSL and go ahead. And it's got my changes out here. It says, hello BICS, sorry for going off topic yesterday. I spoke for an hour. I did not talk about idea to prod, but here it is. We had the idea. That's when I played the role of a product owner asking an issue. Then I played the role of a developer making the change. Now it's been deployed automatically. Now it's just a matter of merging this MR, and the same pipeline is going to execute and deploy this in my prod environment as well. So just a quick overview of environments. Where's it gone? Operations environments, to just give you what's happening here. We have 3 environments now: a staging environment, production environment, and specifically for this change that I'm making for you, we have a review environment as well. You get a lot of information. For example, you go to metrics and you see all this metrics, which will load hopefully. Let me select review environment actually. So you can see that this is going to show me metrics for this environment out here. Hopefully when it loads, it's, yeah, there you go. You see uptime, you see core usage, memory usage, and you see a lot of information. A quick introduction of where was this deployed. This was deployed on a Kubernetes cluster that I've got integrated with my application. So I have a cluster running on Google, so it's on GKE, and I've got the integration made, and automatically the production for my my project was deployed here, and the staging was done here. And when I made that specific change for you, it was deployed out here. Now, it might be that in the real world, you have a cluster specific for each environment. So you can define the scope out here. So you can decide the production environment goes to the prod cluster and the likes. But yeah, there's that. We've quickly just seen the overall story where we have a change that needs to be made. We've made the change and we've been able to deploy that real time. Again, I did zero ops work. I did zero pipelines work. Everything was there for me. I was able to be productive and I was able to capture all of this information as quickly as possible. That's the gist of the idea to prod demo. Again, a lot of apologies for really not sharing this yesterday. It was part of the agenda, but then I got into like an engrossing conversation with some of your team members, and then we just went somewhere else. Anyway, I hope this is useful for you, and yeah, I look forward to the next sessions. Thank you.